Good morning, dear students. I am Dr. Bhatri Srinivas, Professor of Chemistry in Sri Academy, Hyderabad. So today we are going to discuss about the one more reaction intermediate, that is the free radical. It is very important for the many reactions, organic reactions, because this one we have to learn carefully. In this many mechanism, it will be very useful in different types of mechanisms. Okay, so free radical. What is meant by free radical? First of all, already in the introduction chapter, already we discussed about the free radicals. This is the third one, free radicals. Free radicals. Few free radicals we have discussed earlier. So how can you define this one? A free radical may be defined as species that contain one or more unpaired electrons. One or more unpaired electrons. Alkyl radicals are very reactive. Alkyl radicals. Earlier we have seen the alkyl radical, R means alkyl. And their lifetimes are extremely short in solutions, but they can be kept for a relatively long period in frozen time. So in a solution it's a very short time, but in frozen you have to freeze it within the crystal's lattice of their molecules. The frozen and solution, two things are there. In a solution there's a very short life, but we can frozen this molecule so little bit higher than the solution. So first of all, we have to see the structure. There are two types of free radicals there: sp2 hybridized free radical and sp3 hybridized free radical. So the structure is this one. The structure 1, we have to see the structure 1 is sp2 hybridized. So these are the free radicals. Okay, free radicals. We can see this one is the R, alkyl. So one more alkyl. So these are the three types of alkyls: R1, R dash, R2. So R. So these are the free radicals. Here, this is look like a plain R. Plain R. This is a plane and bearing two electrons. So sp2 hybridized. So this is the structure of sp2 free radicals. In the case of sp3 hybridized, that is the structure. Neither planar nor tetrad, bearing unpaired electrons. Neither now planar nor tetrad. So this is structure. So here the structure is like this. It's the one electron. So this is the dash. So mean one is the we can write it dotted one. So stereochemistry, this is one. So it will change this. So this is a sp3 hybridized. Only one unpaired electron is there. Only one unpaired electron. So mean free radicals are just two types of free radical structures are there. One is planar The second one is the neither planar nor tetrahedral. but is having is only one electron here, two electrons. One is sp3 hybridized, another one is the sp2 hybridized free radicals. So now how they are forming, mean there is a generation of free radicals. Generation of free radicals we have to see. So generally we know that thermal cleavage, photochemical cleavage, please note down. Generation of free radical. Generation of free radicals. The first one is the thermal cleavage. Thermal cleavage. Thermal cleavage. Organic molecules, high temperature in the gas phase results formation of free radicals. Generally, peroxides, you know the peroxides are COO and ester sweet. This is the. So in thermal condition, this will form COO. So this is the free radicals. Free radical formation takes place. This one is the free radical. In thermal cleavage, all peroxides are formed like this is called the free radical. Free radicals. Free radicals. In the case of nitrates, that is Rn double bond N. Here also thermal cleavage. So they form the empty gas. So this is also free radical. These two are two examples are for thermal cleavage. And photochemical, some photochemical cleavage also there, photochemical reactions in the presence of UV light. UV light, in the presence of UV light. The generation of free radical in the presence of light around 600 to 300 nanometers. That is, please note down this one. And the second one is the photochemical. Photochemical cleavage 600 to 300 nanometers. 300 nanometers. Around 300 nanometers. Here generally halogens, carbonyl compounds might generate the free radicals. They are, for example, ketones, carbonyl compounds. This one under UV light, so they form like this. This one, two alkyl radical and this carbonyl radical. This is one example in a photochemical. And second example, halogens X. For example, you have to take chlorine, Cl2. So Cl2 undergoes H nu, that is a Cl free radical. Cl free radical. So these are the photochemical cleavages takes place. And we have to take another rearrangement free radicals. Rearrangement, one more examples. This is important for the examination point of view. This one, third one is the rearrangement. So how they are the rearrangement? The third one is the rearrangement free radicals. Rearrangement free radicals. Rearrange free radical. So we have to take the one example. CH2 is the free radical. So this is already free radical. So rearrange this one. If trialkyls are there. So here So what happened? This one. This is the rearranged. This one. So rearranged this alkyl group arranged or attached to the CH2 group. So mean here free radical takes place, and earlier this one. This is called the rearrangement. Rearranged. Just rearrangement of the free radicals. Okay, the generation is over, structure and generation. Now some factors we have to look the factors. Factors. What are the factors? Factors mainly they are that depend upon the resonance, hyperconjugations, mean the stability of carbon radicals. The stability of free radical, the carbon free radicals, is favored by resonance and hyperconjugations. So we know that resonance mean the free radical. For example, this is the free radical. This is the benzene containing. This is one is the free radical, for example. So we know that here the resonance structure of this one is ortho and para. Ortho and para. We can rearrange this one. This one, either this side or this side, para radical is there. And CH2 mean ortho position and para position. So this is the resonance, the stabilized, it's favored by the stabilized, mean by resonance. These are the resonance structures, ortho position and para. Then ortho will come this side. Then again one more will come. This one. These are the resonance structures. Okay, one more example. For example, alkene. Alkene we have to take one example of alkene. So CH2 double bond CH2 CH2 free radicals. This is the free radical. So how? These are the two types of resonance structures there. Here, see here. This one. So one more example. One. So these are the some factors. Resonance, and by hyperconjugation. We have the hyperconjugation. The stability of free radicals increased by the methyl groups. We know the methyl radical, ethyl radical, propyl radical, tertiary butyl radical. So what is the order? That is important. What is the order of the free radicals, especially by hyperconjugation? Please note down all these things. Methyl free radical. Methyl free radical is less than the ethyl free radical. It's less than the ethyl free radical. Is less than the propyl free radical. Is less than the tertiary butyl. This one. Take this compound CH3 and CH3. This is the compound trimethyl. Tertiary carbonyl. The structure. That is the structure of this one. So if you, in the case we have to remove one hydrogen from one molecule, you have to remove that. So here, remove any methyl group from one hydrogen. Any one of these three methyl groups are there. You remove one hydrogen from there. So what happened? This one come to this side. For example, you remove from here CH2. Then CH3. So this is a hydrogen free radical generation. Hydrogen free radical generation takes place. Hydrogen. Either any, or we can say like this one. Hydrogen free radical. So like this. So this is called the hyperconjugation. Hyperconjugation mean that is depend upon the methyl groups. Okay, so that is the reaction intermediate. Today we have discussed that free radicals. So free radicals are little small chapter, but it's only examples are important. Examples are important. In the next class, we will discuss about the carbines and nitrines. So thank you very much.